Today, we're going to get into the story behind a really important programming language. But look, this isn't just about code and syntax. Not at all. It's a story about innovation, about getting frustrated, and about the personal journey of one creator who decided he was going to take on a giant.
And that really gets to the heart of it, right? What actually happens when you try to fix a giant. See, in our story, the giant is the Java programming language, and the person trying to fix it, Martin Odersky. His journey would end up changing the entire landscape of software development.
So let's start with Chapter 1, a fascination with compilers. Because a story like this doesn't begin with some grand, complicated plan. No, it starts with a simple fascination, a spark, that lit up in the early days of computing and set one guy on a collision course with a software behemoth.
I mean, that quote from Martin Odersky just says it all, doesn't it? This wasn't just a career path for him. It was a calling. The second he figured out what a compiler actually did, turning human ideas into something a machine understands, he was completely hooked. And that one obsession would basically drive every big decision he made from then on.
And this wasn't just some academic interest, It led to real-world stuff fast. By the mid-'80s, he'd already co-created a compiler and sold it to Borland, which was a huge deal at the time. They even offered him a job. But here's the kicker. He said no. Instead of taking the money and the cool industry job, he decided to go get a PhD with Nicholas Wirth, the guy who invented Pascal. He chose deep fundamental knowledge over a quick paycheck.
All right, Section 2, Improving a Programming Giant. So after the PhD, Odersky's path takes him right into the belly of the beast, Java, the biggest language on the planet. But here's the thing, his goal wasn't to compete with it. He wanted to make it better, from the inside.
You got to remember, in the mid-'90s, Java was just taking over everything. It was unstoppable. So much so that an assistant told Odersky's colleague, Phil Wadler, that this Java thing was going to bury them in all their work in functional programming. So what did they do? They basically said, well, if you can't beat them, make them better. And they set out to inject all these powerful functional programming ideas right into Java.
And you can see how their influence just grew step by step. First, there was this experimental language called Pizza. Yeah, Pizza, in '96. It was proof that you could add these new features to Java, and that got the attention of Sun Microsystems, the folks who made Java. That led to Step 2, Generic Java, or GJ, a direct collaboration to get one key feature, generics, into the language. And the result? By 2004, their work was a core part of Java 5, totally changing the game for millions of developers.
Now check this out. By the year 2000, that's a full 4 years before their features were officially in the language, Sun Microsystems adopted Odersky's compiler as the new standard for all of Java. Why? Simple. It was just better. It was more stable and better built than their own. He was already building a better Java than the people who invented Java.
So now we're at Chapter 3, Frustration Fuels Innovation. You'd think that would be the end of the story, right? He won. But working inside the walls of a giant comes with its own problems. All that success was actually leading to a critical moment, a breaking point where fixing things from the inside just wasn't going to cut it anymore.
This quote from Odersky really hits at the heart of the problem. He felt handcuffed. He could see better, more elegant ways to solve problems, but he was stuck. He was totally bound by the need for Java to be backwards compatible no matter what. That creative friction was just building and building.
So that frustration led to a massive decision. It was time to start over with a completely clean slate. But here was the masterstroke. He wasn't going to just abandon the entire ecosystem. The plan was to build a new language that could still run on the Java Virtual Machine, the JVM. This gave him total creative freedom while still tapping into one of the biggest, most powerful software platforms on Earth.
Part 4. Forging a new path. So what happens when you finally get that clean sheet of paper? Well, this next part of the story is all about the messy, difficult process of turning a beautiful, pure idea into a practical tool that people will actually want to use.
His team had lived on both sides of this fence. Their first attempt at a new language was called Funnel. It was academically brilliant, totally pure and elegant, but also basically impossible for a normal person to use. Then on the other side, you had their work on generic Java, super practical, super useful, but completely boxed in by restrictions. They needed to find a path right down the middle.
And that middle ground, that sweet spot, was Scala. It was born from everything they learned from both Funnel and GG. The whole goal was to create a language that was practical enough for everyday work, but also way more advanced, expressive, and powerful than Java, with all its rigid rules, could ever hope to be.
Okay, part 5, correcting an original sin. So why did it have to be a whole new language? Well, it wasn't just about adding new features. It was about fixing a deep fundamental flaw in Java's original design. A flaw so bad that Odersky himself called it the language's original sin.
Let's break this down. The core problem is something called covariant arrays. Okay, think of it this way. Java let you take a box labeled apples and put it inside a bigger box labeled fruit. Seems logical, right? Apples are a type of fruit. The problem is, Java would then let you try to put an orange into that apples box and boom, your program would crash. This tiny shortcut created a massive hole in the language's safety net.
That original sin metaphor is just perfect. It was a quick hack, something that Java creators did because they were in a hurry and didn't have a better solution at the time, but that one shortcut ended up having these cascading consequences that would pretty much poison every design decision for years to come.
You can literally see the dominoes falling. The initial hack wasn't just a bug that could crash your program. It became a permanent roadblock. Years later, when it was time to add modern features like generics to Java, that original sin made it impossible to do it correctly for arrays. The language was stuck. It couldn't fix its own foundation.
And that brings us to the whole point. The only way to fix the problem was to do the one thing a giant like Java could never ever do: break backwards compatibility. By starting fresh, Scala could just make arrays behave the right way from the ground up. This was the freedom, the clean sheet, that Odersky had been looking for all along.
And this whole story leaves us with a huge question, and it goes way beyond just programming. In anything you do, how do you balance that constant pressure for a quick fix, a simple hack to just get the job done today, against the risk that you're creating an original sin, a foundational flaw that's going to mess up every decision you make tomorrow? It's a challenge every single innovator faces, and the story of Scala is a powerful lesson in why sometimes the only real way forward is to start over with a clean sheet.